In the last few presentations, we completed conversion of decimal number to other number systems. In this lecture, we will do reverse of it. We have binary number and we will convert it to decimal number. I will first generalize the case, others to decimal. The integer part of the number is A0, A1, A2, A3 and the fractional part is A minus 1, A minus 2. And let's say the number is having base r and we want the decimal equivalent of this number. So what we have to do? We have to multiply A0 by r raised to power 0 where r is the base. We have to multiply A1 by r raised to power 1. In the same way, we will multiply A2 by r raised to power 2, A3 by r raised to power 3, and for fractional part also we will do the same thing. We will multiply A minus 1 by r raised to power minus 1 and A minus 2 by r raised to power minus 2. Now we will add all of this. We will add all the results together and this will give us the decimal equivalent of the number. We will take one example. The binary number is 10101.11. This is the binary number and we want decimal equivalent. This is binary point. And this one is having position 0. The 0 is having position 1. In the same way 2, 3, 4. This one is having position minus 1 and this one is having position minus 2. Now we will follow this rule. We have to follow this rule every time when we have to convert any number to decimal. Okay. If you compare this, you will find A0 is equal to 1, this one. A1 is equal to 0. A2 is equal to 1, this is A2. A3 is equal to 0. And A4 is equal to 1. In the same way, A minus 1 is equal to 1 and A minus 2 is equal to 1. And the base is equal to 2. R is equal to 2. Now you have everything to find out the decimal equivalent of this binary number. So let's start. We have to multiply A0 by r raised to power 0. A0 is 1 and r raised to power 0 is 2 raised to power 0. In the same way, we will multiply 0 by 2 raised to power 1 plus 1 by 2 raised to power 2. A3 is 0. So 0 multiplied by 2 raised to power 3. And A4 is 1. So 1 multiplied by 2 raised to power 4. Now we will move to fractional part. A minus 1 is 1. A minus 2 is also 1. So 1 multiplied by 2 raised to power minus 2. This is what we have. Now we will simplify this. 2 raised to power 4 is 16 and when 16 is multiplied by 1 we will have 16. 2 raised to power 3 is 8 and when 8 is multiplied by 0 we will have 0. 2 raised to power 2 is 4 multiplied by 1 is 4. 2 raised to power 1 is 2 multiplied by 0 is 0. 2 raised to power 0 is 1. 1 multiplied by 1 is 1. And 1 multiplied by 2 raised to power minus 1, we can definitely write 1 by 2 raised to power 1 plus 1 by 2 raised to power 2. We can simplify this and we will have 2 raised to power 1 and 2 raised to power 2 as 2 and 4. Now we can easily add this. 16 plus 4 is 20. 20 plus 1 is 21 plus 1 by 2 plus 1 by 4. We can further simplify this as 2 plus 1 by 4 and 2 plus 1 is 3. 3 by 4 is 0.75. So 21 plus 0.75 and this is equal to 21.75. This is the number in decimal. So the decimal equivalent of this binary number is 21.75. So this is how you have to find decimal equivalent of a binary number. Now there is one homework problem for you. Homework problem. The binary number is 1101100.101. This is the binary number and you have to find decimal equivalent of this binary number. You have to follow the same rule, this rule, and you will easily find the decimal equivalent for this binary number. This is all for this presentation. See you in the next one.